Today, lesson 23A, day number 23A, day number 3 of rational number operations. In the first 2 days, our focus was on adding and subtracting. Today, we shift to multiplying and dividing. And before we actually get into any negative fractions or negative decimals, we're going to do what should be a little bit of review from 6th grade, but I have a feeling that some of you didn't learn how to model multiplying and dividing fractions on a number line. So that's the reason why, that for the first time probably all year, the background knowledge is actually in the notes. And so my advice to you is on these 6 or 7 or 8 problems, you make sure that you take very good notes. Reason being, there's a chance that you may have had somebody who didn't show you how to prove why you think something is what you say it is via a number line model with multiplying and dividing fractions. So we're going to start with 3 times 3/4. 3 times 3/4, one way of looking at it is 3 groups of 3/4, much like we talked about the explanation of basic multiplication that you learned in the 3rd grade. So 3 groups of 3/4. So on a number line, one way of showing that would be showing 3 groups of 3/4. And one thing you should notice is between each integer on the number line, I've divided each section up into fourths. So there's one group of 3/4. Here's another group of 3/4. And here's that third group of 3/4. So where have I landed on the number line? At 2 1/4. So that's one way of proving that 3 times 3/4 is really 2 1/4. Now, the mathematical way, of course, of doing that is basically thinking of 3 as 3 over 1 and then multiplying straight across, or seeing if you can do some cross-reducing, which we will come back to, but you can't do any cross-reducing in this one. So it's 9/4, which is 2 1/4. All right, so let's flip it around now. 2/3 times 6. One way of thinking of 2/3 times 6 is 2/3 of a group of 6. 2/3 of a group of 6. So on my number line, I want to go 2/3 of the way from 6, or on my way to 6. So there's 6. I could break this up into thirds like this, and 2 of those 3 groups of thirds would take me to 4. So right there is my 2/3. So that's 2/3 of a group of 6. And on the number line, I have ended at 4. So that means 2/3 times 6 is 4. That's one way of modeling 2/3 times 6. Of course, the mathematical way is 2/3 times 6 over 1. In this one, we could do a little bit of cross-reducing. But I'm going to multiply straight across and then reduce for now. Next problem. What about a fraction times a fraction, like 1/2 times 1/3? One way of modeling this to prove what it is to think of this as 1/2 of a group of 1/3. Well, one way you could do it is with an area model. So there's 1/3, and if I take half of that, it should be clear to you that that's 1/6. And that may have been one way that you modeled fraction times a fraction last year. But on a number line, once again, we're trying to find half of a group of 1/3. Well, notice between 0 and 1, I've broken it up into thirds. And if I take half of that, right there, that leaves me at 1/6. So that's one way of also showing that 1/2 times 1/3 is 1/6. The mathematical way, you can't do any cross-reducing here, so 1/2 times 1/3 is 1/6. Okay, so we did a whole number times a fraction times a whole number, and a fraction times a fraction. So we've kind of taken care of all the possible scenarios there. So now let's shift to division, and I'm going to link this back to things we've been talking about lately. So remember, 27 divided by 9, we all know that that's 3, but it's 3 because 27 equals 3 times 9. And we've got some blank areas we're supposed to be filling in here. And 27 is 3 groups of 9. That's obvious. And or we could flip it around, thinking of the commutative property. 27 equals 9 times 3, which is 27 is 9 groups of 3. So these are ideas that we've already talked about, and it is the commutative property that allows me to flip-flop numbers around adding or multiplication. So another way of thinking of this, let me take a different problem that's not in your notes. 20 divided by 5. We could think of this as 20 is 5 groups of what number? And obviously that's 5 groups of 4 using repeated addition. That's one way of proving that 20 divided by 5 is 4. But we're going to utilize these ideas now with number lines. So our very first one, 12 divided by 3, we're going to think of that like in the last problem as 12 is 3 groups of what number? Well, we all know that that's 4, and one of the reasons why it's 4 is because we have 3 groups of 4 right here to make 12. Now that's obvious, but we're going to apply that idea to fractions now. So once again, 12 is 3 groups of 4, and I just showed that right, the 3 groups of 4 to make 12. So now let's try 4 divided by 2/3, a whole number divided by a fraction. So what we're looking for here is 4 is 2/3 of a group of what number? I'm going to see if you can figure that out with your number line. I'll give you about a minute. So we're trying to figure out 4 is 2/3 of a group of what number? Turn to your shoulder partner right now and talk about what you've come up with modeling with a number line. I'll give you about 1 minute to talk with your shoulder partner. Okay, so I walked around and I looked and I saw a lot of this right here. I saw a lot of thinking of, okay, from 0 to 4, and then I know that that's 2/3 of something. So there's 1/3 and there's 2/3. Well, that's only the part of it. We need to find basically the whole number. So if we went another third out from that, that would of course take us to 6. So 4 is 2/3 of a group of 6. That's a mathematical way, or not a mathematical way, but a modeling way of showing with the number line that 4 divided by 2/3 is 6. Now, the mathematical way, of course, 4 divided by 2/3 translates to 4 times 3/2. And of course, from there, it's just a multiplication problem, and that's 6. All right, I want you to do the same thing now with the last modeling problem for today, 2/3 divided by 4. And when we're thinking about 2/3 divided by 4, modeling with the number line, we're trying to think of it like this. 2/3 is 4 groups of what number? Let's see if you can figure it out, and then we'll shoulder partner just like we did in the last one. 2/3 is 4 groups of what number? So if we take our number line, and it should be clear to you since it's broken into thirds that that's 1/3, that's 2/3, and then we have 3/3, which is 1. But we're trying to think of this as 2/3 is 4 groups of what number? So from 0 to 2/3, the way it looks right now, it's broken into 2 groups. But we need 2 groups out of 3, so what we're going to need to do is break that into 4 groups, like that. And that, of course, would mean that each group there is 1/6. So 2/3 is 4 groups of 1/6. All right. Mathematical way, 2/3 divided by 4 turns into 2/3 times 1/4. And that, of course, is 2/12, which is 1/6. All right, so I just wanted to review a little bit of the modeling that should have happened last year, regardless of whether it did or it didn't. If I give you a problem like any of these in the homework, you now know how to model them with a number line. But we're going to get away from that right now and deal with these the mathematical way. So when we are discussing a problem like 5, 6 times 9/10, I've been teaching long enough to know that many students coming into the 7th grade just like to multiply straight across and then reduce from there. And I'm telling you right now that from experience that the bigger the numerator and denominator get, the longer it takes to do it that way. Because most people probably wouldn't even see that 15 went into the numerator and denominator. They probably would see that 5 went into it. And then after they reduced that, then they would see 3 again. So what you've done is you've reduced twice when you could probably get away with it by doing it this way. And so we need to move away from just multiplying straight across. I'm not saying that you can't do that, because you of course can, but from experience it takes longer. What you should do is you should cross-reduce or cross-divide or cross-cancel, or however you want to phrase that. But what you're allowed to do here is you're allowed to reduce diagonally, because you're reducing a number from the top with a number from the bottom. So in this problem, this is the way that all of you should be looking at it. 5 goes into 5 once and 10 twice. And hopefully you've at least seen this done before. The number that goes into 6 and 9 is 3. 3 goes into 6 twice and 9 3 times. From there, multiply straight across. And trust me, it takes a lot less time to deal with multiplying fractions or mixed numbers when you try and do it this way. Okay? All right, so I would like everybody to do number 1. So what we should have done here is diagonally with the 3 and the 27, 3 goes into 3 once and 27 9 times. And then with the 8 and the 16, 8 goes into 8 once and 16 twice. And all cross-reducing is it's like an early way of reducing. But you need to realize you can only do that when you're multiplying fractions. Now we multiply straight across, so I believe that the product is 2/9. Now, in a problem like number 2, when we have mixed numbers or integers, we need to turn them into improper fractions first. Could I get all of you to do number 2? All right, so number 2, negative 2 becomes negative 2 over 1. 3 and 1/6 becomes 19 over 6. Now, if we want to cross-reduce, we can. 2 goes into negative 2, negative 1 times. 2 goes into 6 3 times. We can't do any cross-reducing the other way. So now multiply straight across. That's improper. We need to turn that into a mixed number. 3 goes into 19 6 times with a remainder of 1. So therefore, I believe that the product is negative 6 and 1/3. Now, go ahead and do number 3 and number 4, and then we'll shoulder partner both of those. We can do a little bit of cross-reducing here. 7 goes into negative 7, negative 1 times. 7 goes into negative 21, negative 3 times. Multiply straight across now because I can't really do any more cross-reducing. I end up with negative 5 over negative 24, but a negative divided by negative, of course, is a positive. So therefore, I believe that the product is 5/24. Number 4, we'll need to do some converting here to improper fractions first, which gives me this. I can do lots of cross-reducing. 7 goes into negative 7, negative 1 times, and 14 twice. The other direction, 3 goes into 3 once and 15 5 times. And now we multiply straight across, which leaves us with negative 5 over 2, but that is improper. We need to now convert to a mixed number. So I concluded that the product is negative 2 and 1/2. Now a shift to division. And the first set of things here is just hopefully to get you to understand what the relationship between multiplication and division really is. Multiplication and division are inverse operations of each other. So 4 times 3 equals 12. That is equivalent to 4 divided by 1/3 equals 12. 8 divided by 2 equals 4. That is equivalent to 8 times 1/2 is equal to 4. 1/3 divided by 3 equals 1/6. That is equivalent to 1/2 divided by, multiplied by 1/3 equals 1/6. We have inverse operations right here, and here, and then here, and here, and then here, and here. Those should be very, very familiar to you when you're switching from one thing to another. So to divide a fraction, or to divide by a fraction, is to multiply by the reciprocal. So 1/2 divided by 3 equals 1/6. That's how that becomes 1/2 times 1/3. The reciprocal of 3 is 1/3. And we change the operation. Okay? All right, and I'm sure that all of you have seen that before. So, for example, 4/5 divided by 2/3 becomes 4/5 times its reciprocal, so 4/5 times 3/2, and then we just do what we did in all of the previous problems. All right, I would like all of you to do all 6 of those problems. That should be nothing new to you. The only new thing might be the introduction of negative mixed numbers. But go ahead and do all 6 of them. 3/8 divided by 1/2, that is equivalent to 3/8 times 2/1. Do some cross dividing if you can, and of course we can. So I believe that the quotient is 3/4. Number 6, 3/5 divided by negative 3/7 is equivalent to 3/5 times negative 7/3. Cross divide or cross reduce if we can, and we can. Then we need to turn that back into a mixed number. So I concluded that the quotient is -1 2/5. Number 7. Need to do a little bit of converting to improper fractions here. So that turns into -16/9, and that becomes then as a multiplication problem times 3/2. I did a couple of things at once there. Do some cross dividing here. 3 goes into both of those numbers, and then 2 goes into the other 2 numbers. And we get -2 2/3 as the quotient. Number 8. 8/15 divided by 4/5 is equivalent to 8/15 times 5/4. Do some cross dividing. Multiply straight across, so the quotient is 2/3. Number 9. Convert to improper fractions. 5/1 divided by -7/2 is equivalent to 5/1 times -2/7. Multiply straight across because we can't do any cross reducing, so the quotient is -1 3/7. And number 10 is very similar to number 9, and we get, for the quotient, -4. Any questions about any of those problems? All right, so we've done a lot of stuff with fractions. Well, the same rules apply as far as decimal multiplication and decimal division. So that's why I told you, those of you who like to get ahead in the notes, to not go any further, because if 16.8 divided by 1.4 is 12, then will this quotient be positive or negative? Negative 12. If 8.7 times 0.43 is 3.741, will this product be positive or negative? Positive, because a negative times a negative is a positive. If this product is 5.04, will this product be positive or negative? Negative, because a negative times a positive is a negative. And if this quotient is 1.2, will this quotient be positive or negative? Positive. So we just apply the same rules that we had when we were multiplying and dividing integers. Okay? So turn to your shoulder partner. What did you learn today?